Good evening, everyone. Thank you for joining us. So, my name is Baltazar, Chua. I'm a tech addict. I like to play with tech. I also work as a technical architect for Credit Agricole, for those who are not familiar. And forgot to remove that one. I go by the name The Professor. If you're wondering why, I don't know. Perhaps I do boring lectures. But because I'm a nerd, I do on my free time. I don't take care of my kids. I let them go to the neighbors and play with open source stuff. Like I contribute to MicroK8s, if you heard about it, and KEDA. Shameless plug. KEDA was recently graduated from CNCF. So KEDA is a Kubernetes event-driven autoscaler. So my work was I added a scaler for Apache, ActiveMQ, Artemis, and NAT streaming. And yeah, I don't have Twitter. I only have GitHub and LinkedIn. Boring, right? Okay, so that's about me. Let's start with this. So I guess some of you have heard about like your user called in and say the system is slow. And so we started pointing to each other. You're slow, you're slow, you're slow. And maybe 3 weeks later, we found out who is. So one of the things in troubleshooting things is the first step is to really find out what is wrong. If you find out what is wrong, you're more than halfway of solving it. So, so today I'm going to talk about observability. I keep hearing that noise. Observability. So there's a lot of, I would say, monitoring and observability tends to be interchangeable, right? So you talk about monitoring, you talk about observability, but what the hell are they? Well, they are not distinct. They're complementary. So monitoring is about gathering all these metrics so that you can tell if the system is healthy or not, right? So it's just a way to show you that it's not healthy. But observability, on the other hand, is your system exposing its state so that it can help tell you what is wrong. So so this is, you'll see this in the internet. So when we troubleshoot things, the first thing we go to is logs, right? It's the oldest way to troubleshoot a problem in production. Then we have metrics. Metrics are telemetry information, such as your CPU, your I/O, or number of threads. So these are telemetry. We can also say that requests per seconds are a form of telemetry, right? And then we have traces. So traces are born because we do things like microservice, right? So when we were in the monolithic world, the way we troubleshoot things are easy. You know, you go to your system, you see, who's Java guys here? So you can use Visual VM, you'll see everything, right? But microservice, with microservice, we start to distribute the workload to many other systems. It can be written in Python, Node.js, Java, C#, Go, Rust. So it becomes a lot more difficult to narrow down. So there are definitely benefits to microservice, but these are one of the things, some of the things are very hard to grasp or wrap around your head if you don't have the traces. So it's called distributed tracing. So today I'm going to focus more on this, less on metrics and logs. Okay, so observability. So recently, not so long ago, OpenTelemetry is provides a standard way to expose telemetry, logs, and distributed tracing. Used to be this. This industry is very proprietary. If you work on Dynatrace, App Dynamics, maybe Datadog, if you're using it. So they're very proprietary. So what OpenTelemetry wants to achieve is to have a common way of exposing these internal states, regardless of what backend you have, whether it's Datadog, Signos, Honeycomb, and all that. So because they also provide specifications, of course, for vendors to support those telemetry, those information, they came up with a specification, and also SDK. If you have questions, don't hesitate to ask. So it supports several different programming languages. You probably don't see this. It's Rust and Go, Python, Java. And so what are the components of OpenTelemetry? So you have the specifications, how you emit and how the other system will receive it. You have the collector, because you emit telemetry. That means that somewhere it has to collect them. And then instrumentation libraries. These are libraries that instruments, well, obvious, instruments that piece of code. Say, for example, an HTTP library. You can, it instruments the HTTP, you get the request, how long it took, and the response all together. It wraps these, so the OpenTelemetry instrumentation wraps some implementations like gRPC. So you see that. And then I have the telemetry. Then how do I send it to the collector? So we have different kinds of exporter. We can export it to an OpenTelemetry collector, or I can export it to Kafka. I can export it to Jaegar, Zipkin. And oops, sorry. So propagators, what are propagators? Any idea? If I am talking to different services, right? I need to stitch them all around. So I need to pass this trace information to the next guy. So the next guy can pass it to the next guy. So this is called trace propagation. And then crucial thing is that sampling. It's just impossible to take everything, right? So you either we just sample them, so that we don't overload your system. If you're already slow, adding this might not be a good idea. At the same time, because we're going to keep them so that we can visualize them, we don't want to overload or just, the storage where you keep all these things. So these are the main components. It exists for every single SDK, whether you're Java, C#, Go, Rust, Python. I'm gonna, so instrumentation are classified as manual and automated. In Java, for sure, it's usually automated because it has a JVM. You can hook up to the JVM and you can just instrument everything. For some programming language, you don't have that. Rust, you don't have, you have to hand code it. In Go, it also doesn't have, so you have to hand code it. Not interested in showing you automated instrumentation, because otherwise we'll finish in like 2 minutes. I'll show you a piece of code, how you write it in Go, manual instrumentation. Yeah, so as I've said, the list of vendor products, commercial products or open source is growing. So a few months ago, I don't see this, but now they're there. Yeah. So just a clarification, what is distribution here? So distribution is not a fork of open telemetry. It's adding their vendor feature into open telemetry. So it's not a fork. The fifth column here, OTLP, it's a bit new, not so old. They standardize how to talk to a collector to collect the traces or the logs or the metrics. So they call it the OTLP, which is Open Telemetry Protocol, gRPC. And yeah, so what are traces? So used to be not here. Distributed tracing was actually popularized by Zipkin. If you heard of Zipkin. So Zipkin was based on Google Dapper, a paper, how Google stitches all their services and to see where the latency is or which service is slow. So Zipkin took that and they wrote it. They wrote their specification. So Zipkin grew very big. And then there's the other folks from Uber who wrote Jaegar, which is kind of like a competition to Zipkin, and they came up with open tracing. And so eventually open tracing and open census, which is another, there's so many standards, you know. If you don't like a standard, you take it and you create a new standard. So this is what happens. So luckily, so open telemetry is like, okay, we have too many standards. Why don't we take these and standardize it to open telemetry? So if you're using open tracing, that's gone. You're using open census, that's also gone. The tracing is actually simple. This is added to this. Okay, by the way, the tracing is now a W3C standard via the W3C trace context. So you have the version, you have the trace ID. Usually it's in a 64-bit. You have the span ID and whether it's sampled or not. So what does it look like? So everything that passes through, let's say a user clicks on a button, it goes to your service, and then your service calls another set of things. So the first one is actually called the trace. So that's like the root of the traces. And then if it goes to the next one, you will create a parent, which is span now. So they're all linked via that. So it's just like that. And whether this will send the span to the next guy or to the exporter, it's all based on whether it's sampled or not. Questions? Yes, sir. Yes.
So we know that so we have this span ID and trace ID. I hope it works very well when the systems are in the same organization or is connected with the same network. Okay, I'll tell you what it is. Okay, then I'll go into 1 minute. So when systems are distributed outside of your organization, how this trace ID and span ID works? Because as far I know, this trace ID is unique when it is in the same organization and it connects with multiple microservices. Span ID is to be generated, trace ID will be one. How it works when it is distributed across the globe?
Across the globe. Okay. It's going to be hard to do that, first of all, because if you're going to stitch them all together, you need to have an NTP. the time protocol has to be aligned. So the way it generates, I didn't look at it, in fact, but the trace is 64-bit. There's a pattern to generate that. I didn't check whether it's based on MAC address or some time. Right, it does. Right.
If different applications spreading different microservices, then my doubt is whether the trace area is unique at the time or will be having
so the
one application now the trace area and multiple span IDs, and when it comes to organization, it generates again the trace area and the span IDs.
So the trace ID is actually generated by the first one, and then you're gonna pass that to the next guy.
So it means consider CACIB is connecting with both. Okay.
Yeah.
And we have two services connecting to each other. Now in this case, we have only one trace ID.
Yes. Yes. So you carry it over.
Okay.
Yeah. I know. It's I know where you're coming from. I think it's a good idea. It's great if we can do that. But then I start to expose my collector, my visualization to another organization, which I may not want to.
Okay, but what I see is that it works when the systems are the same network and means interconnects in the same JVMs. But if it goes out of their JVM, then
it's still. I think it just the most important thing is that it has to be on the same NTP, network time protocol, so that you don't have the skew. There's a minimum skew it needs. Yeah. So.
That's the doubt I have.
Right. Okay.
When you come out the distributed base, whole world is connected.
Right. Thank you. Thank you for that. I didn't know that, but thank you. All right. So how do we propagate these traces? Well, the simplest one that I used at work is because it doesn't produce a lot of traces. We just wanted to get our hands dirty on it. So we do this. So using the SDK, we just send it to the collector, and then the collector will just stash it into Elasticsearch. We're not using Cassandra, but just that. If you see the Spark job, because the Spark job can aggregate the traces, so it knows the DAG. The service, which service talks to which one. But I think this one is a much better approach, where you use Kafka to buffer the traces as your back pressure. However, there's the open telemetry collector. If you don't want to use Kafka, you can use a telemetry collector, which is just going to send it to Jaeger. So quite simple. So if you're running on containers, you can have a sidecar connecting to your app, or you can run it as a daemon set if you're also in container. But hardly people do that, I think, because this one might be overloaded too. So. Okay, so sampling. I mentioned earlier, like 2 slides ago. Yeah, this one. It tells the next guy whether this trace is sampled or not. So that is head sampling. I start it. I say this is sampled. If this trace goes through every other services, they will just take it, and I will. Okay, this is sampled. I will start capturing. If it's not sampled, then it's a no-all. So you can, it's a very, I would say, very blunt way of sampling. You can sample per 100 traces or per 200, 1,000. But sometimes you want something a bit more control over. So that is what they call tail sampling. So tail sampling is you're going to send everything to the collector, okay? and it will get the span, the trace, and it will determine, do I keep them? Do I keep this? Do I keep that? Based on some sampling configuration. So this is not about saving your app, but it's more saving storage, or maybe you just want to see all error 500 or all error 404, 400, stuff like that. So that's tail sampling. It's a little bit hard. You need your collector to have a lot of memory if you have a very big spans. But it's there. I haven't tried it though. So that's how it works. So it will collect them and then sift through it and leave out some of them. Okay, so yeah, that's basically what I said. So you have the sampling decision SDK and the sampling decision for the tail sampling is at the collector side. Yeah, so this is Jaegar. I think you've seen it before. It shows the trace. You can actually also see errors. Then you can drill down. So when you click on the trace, you'll see what's going on. I'll do a quick demo. So the demo, I have a client in Go. I have 2 services in Rust. I have 1 REST service in Java, and I have my Jaegar. So I'm not pushing my Jaegar spans, traces and spans to Elastic. It's all in memory. So, and I'm running on my ZBook. Let's try. Okay. Sorry. So this is Jaegar. It has some traces, but not for the last hour. So what I'll do now is I will run my Go program. Hide the garbage. So the Go will call the Rust proxy, which goes to the other one, and then it will call the Java REST. This is my Java program. I'm gonna start it first. Oh, I'm using Micrometer. I didn't use OpenTelemetry, the agent. I'm using Micrometer with Spring Boot 3, but I think you can still use OpenTelemetry Java. So let's try it. So I'm gonna run it. Yeah, so it's fine. So there you go. Let's drill down. So what does it mean here? So it started from the account client because it just named my Go service as a account client. It took 24 milliseconds. It calls the proxy. The proxy calls the Rust queue, and then it finishes. And then from the same Go client, it calls the Java program somewhere here. And then I have a local span. This is not distributed. This is within. I call it just dumb service because it doesn't really do anything. And then that's how it is. You can also see some tags, where it came from, some basic stuff, which library you're using.
Can you make the text larger?
Yeah. I don't have a mouse. How do I make this big? So. All right, so you can see some attributes to the span. You can also add yourself some attributes. Say, I'm gonna minimize this one. Yeah, so for normal REST, you'll see the endpoint. And you can also tell that because I purposely use Zipkin format, but the collector can still receive it. You just transform it to the trace. I want to show something here. So yeah, you can actually add custom tags to it. How does it work? So if I go back to here, I can do a demo equal to yay. Is it that? I forgot. For demo, sorry. So it's you can go find. It's in that dump service. So you can find them. So it makes it a little bit easier to find what you're looking for. So how about if I kill this process, like this Java program, and I run this guy again? So what we'll see here, I'm going to remove this one. I'm going to start from the beginning. And so you'll start to see that something went wrong. It can help you, a bit of narrow down where it went wrong. And so I'm gonna show you so I'm gonna start it again. And you see, if your code is slow, you can find it. But what if the network is slow? What will happen? So I'm using ToxiProxy. Is anyone familiar with ToxiProxy? No, but I'll show you. It's actually very cool. It's from Shopify. It can emulate your network, can add latency. It can also pretend your process is down, but not really. You can play with bandwidth. So I'm gonna play with this. I'm gonna add some latency to the service, so upstream. I'm gonna try. So yeah, I'll show you how it looks like first, the configuration. So it's a running proxy that you connect to. So how do I define? So I define that I have the Java service. The proxy will listen on. I'm gonna make it big. Can you see? Or it's too small? Can you see? Text is quite small. Yeah. So the proxy will listen on port 8080, and the upstream is this one. Okay, so it's enabled, but it's not doing anything because there's no toxic. I'll show you if there's list. So you can tell that there's one. No, there's no toxic. none. Okay, so I'm gonna add. So I'm gonna add an upstream. I'm going to add a 300 seconds upstream, meaning from the Go client when it's calling the Java service. There's a delay of 3 seconds. So you'll see that it's added, and I'm going to try it again. Yeah. Let's come back here. So it's still there, but so how do we read this? So it took from this to that, it's about 3 seconds. So you can see from here that it started around 3.16. So that's how you read it. There's also downstream. So the response back to your service, if it's slow, it will show you. Maybe we can add that. Yeah, I'll just do that one. So let's say I add 1 second. Run it again. Let's try. How does it look like now? Yeah. So you'll see that it ends here and then it adds another second. So earlier it was all the way here, and now it's here, and then there's another second that we will see because we added downstream delay. So if you want to emulate slow network, toxic proxy is great. And quickly show you how it looks like in Go. If you are interested, I'll do it anyway. So the first thing that you do is to initialize the trace. I'm using insecure, but don't do that in real life. And then I will name my service, account client, and then I set it. So this is just initializing it. And when I want to use it, I'll go, this is how I have to do it. It's because it's manual instrumentation, so I have to explicitly put those. And then I also wrap it around the instrumentation library that I use. It's not so bad. It's just there's a bit of boilerplate over Java where you have annotations and you're all happy, like this. Yeah. So for micrometer, you just was good. Yeah. I don't know the shortcut. Do you know the shortcut? I use the mouse actually. Yeah. No, it's not happy. Yeah. No. No. Anyway, it's a small one. It's just add observe, then it will show up. So that's it. Oh yeah, thank you for reminding me that. So there's some cool feature in Jaeger where you can actually see which are from what service talks to another one. So if you're using Elasticsearch, you will want to use the Spark job that will stitch them together. But for in-memory, it's easy to have it there. There are other menus here that I don't feel like it makes sense because it's comparing two traces. I was hoping that you can compare the latency, but no, it's just comparing whether it's missing this trace. So it's not very helpful for now. Monitor, it's supposed to be connected to, you can connect it to Prometheus, and you can have some dashboard here, which I couldn't make it work. And that's it. I'm done. Questions? No. Oh, I can't believe you don't have question. No question? All good? Okay, thank you. Okay.
Auto instrumentation is possible in Go also, right?
No, not in this one. I checked it out. They don't have auto instrumentation for Go. Same with Rust. But they have in most JavaScript, Java, C#, I think.
So how does it work with sessions enabled application? So for particular application, sessions are enabled, and sometimes you can also restart the session and use it. So how does it work for that?
So it's actually independent on the you're talking about HTTP session? Yeah. So it's independent from that. It's just a HTTP session. Usually, if you have it sticky session, it will just direct to the same node, but it will still flow like that.
Okay.
So it will carry into the header, the HTTP header, the trace context.
Okay. So the trace all will be remaining the same.
Yes.
Oh.
The trace ID will be added to the HTTP header. Yeah, it will still send.
Oh.
Yeah, you will have you have missing traces.
Yeah, and another performance, like suppose we are adding to our existing application or existing service this traceability. So how it is will it be adding to the bottleneck of that? Like how do this traces are like done in a very quick time. So how is it been handled?
Yeah, so the SDK, yeah, there's definitely an overhead. About how many percent? If you sample everything, I'm going to say don't do that. But the SDK, the way it propagates, so it's asynchronous. So the SDK, you just say you want to send, but it's not really sending immediately. So it batches it and then send. I was actually very slow when I was showing it to you, but sometimes I'll see that only 2 traces is there, and I have to wait for a few seconds, then it shows up. So it batches them before sending out. Yeah. So the good thing is that it's free, it's open source, and it's supported by many vendors.
Basically works in case of database or simple.
Oh, that's hard. Async is hard because you lose the context. It's on a different thread. There's a big, I think there's a micrometer, at least maybe sleuth, isn't great for reactive. It loses that thread context. Yeah, it's hard. Oh yeah. I think you'll see. You will see that it's adding those traces. Yeah.
Consider that as service get another service, and it is kind of it's not failed at the first step itself.
Right.
And again, your reactive mind replace 3 times.
Right. So you will still see. So the good thing is that you see that it tried 3 times instead of just thinking that it didn't do.
I compare the 3 times retry.
Mhm.
That case, all the tools
Oh, the same. Oh, you will, because it added some time. So you will see one after the other.
We have multiple long monitoring, especially kind of thing. We have Splunk, we have L, we have database, lot of things. What Jaeger gives you better when compared to other open source or the license modes?
Okay. Right. I am not paid by Jaeger, so I think that the function here is I'm not going to say anything about vendor products that I don't use. Say Splunk, I heard it's great. Well, it gives you option that because it's not that difficult to run this thing. It's a single binary if you want to run. Okay.
Not talking about the tool that either you want to showcase this tool or you're teaching the concept of observability. If you are teaching the concept of observability, then it's fine. But if you talk about Jaeger, there are 100 things that you can say.
Oh yes.
We cannot take as a version to going to the corporate world to ask them to implement it. Maybe it is to learn the concept of observability, you can take the traces of it or using any of your whatever the micrometer or BTS, whatever it is, you can see that.
I was talking, yes, the concept of observability, how important it is, and how it can help you, you know, if you wake up at 3, you get cold, somewhere to diagnose. So yeah, it's well, Jaeger is the one that's so easy to use, but the concept is the same, regardless of the tool you use. Elastic, they also have this. Loki, no, Tempo for Grafana. Well, the idea here is to share that you can use open telemetry at the same time with different products. Okay. So Jaeger is just one of the more popular ones.
So to get the dynamics, to have the visualize the getting the dynamics license, configuring the server will be problems. It's not that easy. And especially when you're moving to Microsevices or the parts, to configure, to get the license to monitor, this dynamic nature will be end up being taking a lot of money. So this is like a simple thing, 4 months dynamics, you can configure and get that's the advantage it looks. When you compare,
you can use Dynatrace. It's actually a great tool. No, I'm not saying that.
If you see the diagram, we cannot, I don't think it's a stable if you corporate world to connect with the distributed systems. What I can see now.
Define corporate.
I don't know, maybe I worked on ELK, I worked on Splunk, I worked on Dynatrace and Prometheus and Grafana. It's part of my work, but if compared to that, I know that ELK, we have enterprise version on open source as well, but ELK is much better than this what I can see. Except that UI.
Oh, the Jaeger doesn't have logs, so it's not comparable to ELK.
And that is where we are.
Understood.
Thanks for the questions. We are running short of time.
So thank you very much.
If you have,
Yeah, sure. But thank you.
Thank you.